So last class we have discussed about sorry, I was unable to come offline until I get, because it's not good to travel. Okay, so maybe another 2-3 class I take online. Still, we will be having doubts. Recordings will be there. If you face any difficulty offline, anyhow I will come back. No? At that time you can ask, or in the next class itself, during the online class only you can ask. So now, so we have discussed about pandas. So we were discussing about pandas, and so my screen, I have shared the screen, right? I think I have shared the screen. Yes. Okay. So pandas are special type of third-party library, third-party application that we use in Python. So, okay. So two types we have discussed. One is pd.series, another one is pd.dataframe. pd.dataframe. So these two things I know we have discussed in the last class. We have discussed in the last class about these two. How to convert, means why it is used to keep the data in the tabular. So look at this. Whenever you do it in pd.series, it will come in the form of a table. So that we have already discussed yesterday. And if anything that is in the form of a dictionary can be converted in the form of a row column data, whether it's a pd.series or whether it is a pd.dataframe, that doesn't matter. But whenever you use pandas, so the arrangement will be in the row column. So this general concept of using pandas, why? Because why we use pandas, what is the purpose we are going to use pandas? Just because it is used, what is that, we are going to use it because it's RDBMS framework, and also we are going to use it because it is going to be easier for analysis. You can do any type of data analysis. Yeah. So pandas is very important library if you are working as a data engineer, data analyst, or a data science professional, or whatever it is. Okay. So now today's session, what I am going to discuss is about so still more extension of whatever we have discussed. So this series and all, and indexing and all, I have told you in the last class. I am just reminding you this series, indexing. So index, if you want to start the index from 1 2 3 4, it is possible. If you want to access, see, pandas is also can be accessed, just like your look at this. So this is a pd.series. These are the values 11, 12, 13, 14, 15. pd.series. Inside that I have given a series of lists. Index I am passing. I don't want to start from 0. I am starting from 1. Data type I am giving it as integer. Okay. See, look at this. So pandas. So if you just import this, and if you want to, so first I will import pandas and numpy, and then I will execute that. So what happens here, if you execute this, see, look at this, it index started from 1 2 3 4 5. So, and pandas is just like your list, just like your tuple or whatever it is. So pandas can be accessed with the help of indexing. See, look at this, S of 4. What is, yes, what, any doubt? Someone wants to say something? Okay. So pandas can be indexed, just like your list can be indexed, your tuple can be indexed, even your data frame has to be indexed. And means if you want to see S of 4, so SSV, I want to find out what is there. See, you have given the index. Now it is not going to start from 0. If you are not going to give anything, it will start from 0. So suppose if you, so what is this, what error you will get here? See, look at this key error. 0 is not there, 0 is not at all there. key is not there. Keys are going to be uh, key is itself is not there, so by default it will start from 1. So that is the reason. So pandas can be accessed with the help of indexing. See, accessing, so you can access anything. So apart from that, you can do anything. So if you want to retrieve the third element, you can retrieve. You can if you want to just like first look at this. Now you see just how you are doing in the list. See, it will see what is this. It will start 1. So except 1. Look at this. So the indexing is quite different here. So 2, 3, 4, 5. So look at this. If I want plus 3 here, so what is going to happen? So S of 1 is to 3. It will start from 1 and it will end at, look at this, 3. It will start from 1 and it will end at 3. So here in pandas, the indexing works like this, not just like the list. What is that? It will start from 0. It is not going to include whatever. See, 1 means it's not going to include 1 here. It's going to start from after 1. So 3 means it will include 3. So that is indexing, that formatting that we follow in pandas. So that is what we are saying here. So look at this, for example. See, 10, you have a series 10, 20, 30, 40, 50, 60, 70. 2 means what? This is 0, this is 1, this is 2. So 2 to 5. So pandas from 2 to 5. So look at this. You have 2, 4, 0. So what is this? 2 to 5.
The screen isn't visible, sir.
Screen is not visible. Oh, 1 minute. Okay, 1 minute. I will share it again. Now is it visible? Tell me whether the screen is visible.
No, sir.
No. Okay. Okay. 1 minute. I will start presenting. From when it is not visible? From now only? Or okay. Yeah, it's visible for few people. Sushmita, she is able to see why you cannot see the screen. Serena, can you join back? Go out and come in so that your screen will be visible. Yeah. So okay, fine, that's fine. So hope my screen is visible. Yes. So look here. Someone wants to join. Yes. Okay. So what I was telling, yeah, I was trying to index this. See, look at this. If I index from 0 to 5, so let us say 0. Okay, we are not given any index here. Default index it's good. See, it's if it is 0, it is going to give you all the values. So okay, you leave it. You will go from here. See, starting from 0, all the values it will give, whatever it is there. This is the default indexing, 0 to 7. So if you want to whichever the value you want, you do it. So that value it will give. Okay. So if you want from 2, so that is going to, so start all same as whatever the list, start, stop, and if you want to give any start and stop and the space or the steps, start, stop and the steps. So start is optional. Again, if you are not going to give anything, it will take from default 0. Step is also optional, but you should end it. So look at this, starting from 2. So this is 0, this is 1, this is 2. So it will start from 30. Yes, it started from 30. So till where? 5. 5 means 5 minus 1 till 4. So 0, 1, 2, 3, 4. So till 50. Yes, till 50. And in between this step is 2 I have given. Means one after the other. So if I give 1, what is going to happen here? Step. So look at this, 40 also will come from 30 to 50. We have missed 40 because I gave the step as 2. Now I am giving it as 1. So now if I am going to enter here, look at this, start, this is start is 2, it is starting from 2 index. Yes, end point is 5. 5 means 5 minus 1. So 5 minus 1 means how much? Fourth index. This is 0, 1, 2, 3, 4. Fourth index you have value of 50. Yes, this is the fourth index. You have the value of 50. It will end at this one. But the step is one step each. So started from 30, one step, then next is 40, and another one step, next is 50. So look at this. So like this. So you got 30. After 30 you got 40. Then after that you got 50. So same thing as whatever we are doing it in list. Okay. So pandas series can be indexed. Pandas data frame can be indexed with the help of key value pairs. So similarly, negative indexing possible. Negative indexing is, this is start. Minus 3 means what? So this is minus 1. This is minus 2. Minus 3. So it will begin from minus 3. It will begin from minus 3 means 39. Yes, it began from 39. Okay. From there it will start the indexing. So look at this. It will be called as 1. And till where? What is the end point? Till minus 1. Minus 1 means minus. This is minus 1. Minus 1 means minus 1. Minus 1. So n minus 1. Minus 1 is minus 2 till 89. So look at this. So negative indexing, my suggestion is either follow positive indexing or follow negative. I never use negative indexing and I am not comfortable because to positive, negative, that confuses my mind. So usually I use positive indexing only to access last 5 rows or last 2 rows or last row. I will go with negative indexing. That's all. Not to get the slices like this. I will never use negative indexing. Okay. Any doubts still here? Okay. I think you are comfortable. Similarly, yesterday, bounce rate also I told you. NaN values. How NaN values? Last class I have discussed this. What are NaN? Not a number. So NaN values has to be replaced. So look at this. This is actually not NaN. This is a string value. Okay. So anyhow, so we have, for your understanding, see, look at this. This dictionary. So key value pair. So you have a key. You have a list. Inside the list you have a lot of values. 1, 2, 3, 4, 5, 6, 7, 8. So these are the key value pairs you have. Okay. Similarly, you have visitors and bounce rates here. So these values of these key value pairs. So key is bounce rate, key is visitor, key is day, and for each day from Monday to Saturday, 7 days you have, and visitors will be visiting all 7 days, and all 7 days you are checking the bounce rate of the whatever the vehicle you are going to use. So that you can convert that into data frame. So you have series of values that will become rows, and you have attributes, that is key attributes. Those key attributes will become column attributes: day, visitors, and bounce rate. And if you are not going to give by default, the indexing will start from 0 for the rows. Indexing will start from 0 for the rows. So like this, what is that? Pandas already we have last class I have showed you. So we will check for the null values using df.isNull.sum. This we checked in the last class also, I remember. So similarly, this also I have told you. So and also now you look at this. So this is about key value pairs. See, what is this? This is a list. List is converted into pandas with the help of series. Now you see, This is what is this? Tell me, what is this? This is also dictionary. This can be converted. Here also dictionary. Inside the dictionary you have list. So key value plus converted into data frame. Not just list and dictionary, also numpy array, np dot array, numpy array. So this also can be converted into data frame. Of course, yes, we converted. So look at this, is a two-dimensional numpy array. We are converting this into data frame. So look at this, we are converting. So if you are not going to give anything, so because numpy array, nothing will be there except numbers. It's a one-dimensional, sorry, it's a unidimensional. You are only used for numerical data only you have. Apart from that, nothing else. Numpy array is a pure number. So nothing else you will be having. Even the what is, you will get a number. That's all. You get some value. You don't know what it is. You will be knowing as per the specific project requirement. You will be knowing the outcome. What is that number? That you will be knowing. But that cannot be specified. That is not going to come along with the output, right? So just numbers will be there. So this is the numbers. So anyhow, so such kind of attributes are not there by default. Both to the columns as well as to the rows, indexing will start from 0, 1, 2, 3. Here also 0, 1, 2, 3. So numpy array can be converted into data frame. Key value pairs can be converted into data frame. List can be converted into data frame. Tuples also can be converted into data frame. Okay. So all these are possibilities. So look at this. So anything can be converted. So list converted into data frame. So like this. So converting any form of data into data frames, you should be comfortable. Okay. So look at this, list inside a list converted into data frame, possible. List inside a tuple converted into data frame, possible. So look at this, you have a series of list. So inside that list you have Alex and their numbers, Bob and their numbers, Clark and their numbers. So look at this here. What is the difference here? This is a list inside a list. If it is a, look at this here, it's a dictionary written inside a flower bracket. So whenever it is written inside a flower bracket and you convert, key becomes the column name automatically when you convert that into data frame, right? So but here, look at this. For example, this is a dictionary. You converted that. Okay, if you, okay, I'll do one thing. I'll say this, I'll convert, instead of series, I'll convert this into pd dot data frame. So now you see what happened. Okay. So key value pair. Keys and values. So if I convert, look at this, what happened here? Key value, I mean, see, this has to be not just a string, it should be like this in the form of a list. Now you see what happened when you convert this into data frame. By default, key becomes the column name. So but here, this is a dictionary. Inside the dictionary you have key, and values is written in the list. Values are written in list. When you convert that into data frame, by default the key values, sorry, the keys, that is name and age, became column names. But here you look at this here, this is not a dictionary, this is a list inside a list. So obviously what is going to happen? So here nothing is going to be there, only this is going to be command fitting inside a row values, no column values. You can, it's going to be a row values. So there is, so that is the difference. So you should understand the business logic and what parameters has to be there, where you have to fit in the data, which form of data is coming, where how it has to be framed. That is up to your sense, but you should be knowing the logic, where to use, how to use it. Okay. So similarly, okay, this and all I have told you. Same example. This same List and dictionary, list and dictionary. See, list inside list. See, this I have already, this already I told already. Okay, this also I think I am repeating. Okay, now look at this list inside a list. This is one list, this together is one element, and this together is one more element, plus this together is one element. Inside this, these together, these two are separate. What is this? Age and this one is separate. So this is, if you convert this to data frame, so something like this. Yes, correct. So like this, so you can convert anything into data frame. Possibilities are there. Okay. So look at this. This till here I have already told you. No problem. I have told you again. I am recording. It's okay. So NaN values are inserted here. Look at this. Why NaN values are inserted here? Here A is there, B is not there. A, B, C. So B is not there. So NaN value got inserted. So look at this. When I am going to print, how I am printing? So data is this one. List, inside the list you have the dictionary possible. So you convert this data, I am putting this data inside the data frame. Indexing I am giving, because this is not a dictionary, this is a list. Outer structure is list, inside the list you have dictionary. So indexing, column what should be there I am defining, otherwise it will be 0 and 1. First and second, that should be the row. By default index means it will take row first, and columns ABC I have defined it, because this is ABC. These are the columns, key value pairs. So you are defining the columns. So like this. So wherever NaN values, whenever the values are not present, this will come. Okay. So like this. So till here. Okay. Then you can add same. See, you can add the data. You can append. See, just like your what is that list, you can append, right? In the same way here also you can append the data frames. So look at this, I am defining the list inside a list. Here also list inside a list. Indexing I am giving same, first and second to distinguish. Here I am giving the index third and fourth. Columns are same, AB, AB. So append means what is going to happen. So look at this, you can append it row wise, column wise, your wish, but it's better. So if you are not going to specify anything, by default it is going to append. Append means what? It is going to add at the last. Append last, at the end you are going to append it. So this is df1, df2. So this is actually df1. So if you want to what is this, you can check. So this is print df1. So df1. So just check it and see. Here also you can check and see. df2. So then df1 plus df2, what is going to happen, you can see. So look at this, df1 is this one, right? So this is your df1. So I will do one thing, I will put print bar in here, so that we get some. So look here. So what is this? This is df1, 1 2 3 4, 1 2 3 4, first second. What is this? 5 6 7 8, 5 6 7 8. Column you have specified AB, third and fourth, third and fourth. So if you want to append, so obviously it will append. So df1 dot append df2. First df1 will come, yes, 1 2 3 4. On df1, the df2 values. What is this? These values, 5 6 7 8. 5 6 value come and fit here. So you can append. So you can concatenation, because you have to concat, you have to merge. See, these are operations. See, these operations needs to be done. So I am defining one variable df dot, your wish, you can name anything, df dot combine. I am using pandas function pd. All these are inbuilt functions. So pandas inbuilt functions, pandas pd dot concat, pd dot append, pd dot merge, pd dot series, pd dot data frame, pd dot plot. All these are inbuilt functions. So pd dot concat. So pass on the value of, see, you have df1 here. You have stored df2, so pass on the value of df1 and df2. So look at this. If you want to concat, see, it is going to give it like this. See, you are concatenating. So let us check if it's going to work. Axis is equal to 1. See what happened here, what I did. So 1 minute. See here, before this, so it was like this. It is appending, concat and append. What is the difference? Same, na? This is append and this is concat. This is also adding at the end only. Nothing much, no much changes. Okay, but when you, by default it will add at the by default it will add with the help of rows. So when you mention axis is equal to 1, it will not append on concat or append on the rows. It will actually append on the concat on the columns. Even you can do the same thing for here also. So suppose here if I am going to, okay, append here, wait, I will say comma axis is equal to 1. Axis is append, it will not work. Okay, only concat will. This will work. Okay, so if you concat axis is equal to 1, look at this, A B. So here it is going to concat like this. See, nan values, nothing is there here, so it is nan. So this is not going to work. So usually we concatenate or append row wise only, because if you are not going to concatenate row wise, if you are going to concatenate or if you are going to club it column wise, what is going to happen? You are going to lose the data, because sometimes it is going to remove, but if you are going to merge, some sort of duplicates are going to be removed and the data is lost. Correct or not? In SQL you have done lot of joins. When I am going to join certain things, you are going to apply certain conditions. Left join, right join, whatever the joins are, full join, inner join, so many things, whatever you do. Some sort of data is lost. But our intention here in Pandas or in data analysis to keep as much as data as possible, not to eliminate the data. Our intention is not to lose data. Simply merging, you can simply you cannot do whatever I like, nothing like that. Okay, so that is regarding the concat, and that is about, yeah, this I have already. One more thing. What is this about pandas? Okay, so just before this, here, you see df. What is there? Where is df? Okay, this is df. Okay. So let us understand one function here. So first I will pass on the value of x. X I am not going to use anywhere. Using anywhere? No. Okay. And see, this is, I am generating a random that you can generate a random data frame with the help of a numpy function. np.random.rand n numbers in the form of 9 rows, 5 columns. Column name should be A, B, C, D, E, and this all numpy values should be converted into data frame. So I am bringing them, I am placing them inside pd.data frame function. df is equal to pd.data. So this is what you got. These are the values what you got. So now you see, this is df. So when you converted this is a data frame, right? So look at this. See, this is the difference. Print df. This is also row column data. It will come like this. If you just put df, it will come like this. Whatever way you are comfortable, you wish. So you have ilog function. So just like simple slicing in data frame, you have one more function called as ilock. This also what is that? Inbuilt function. So whenever df is equal to pd data frame, so you have ilock function. So what is this ilock? So let us see. For example, mm, okay, analyze this. So df of ilock 2 is to 3, comma 3 is to 4. What is this 2 is to 3, 3 is to 4? You let us understand. Okay. So 2 means what? For the rows, okay, and it is for the rows. So data frame, you have to series, list, indexing is very simple. Why? Because you have just one. It's a one-dimensional data. Okay, only one row you will be having only single row. Okay, and single row will be having multiple values will be having. But here you have rows will be several rows and multiple columns will be having. So here it will begin from second row and it will end at third row. So look at this, and it will begin from the comma means this is referring to row and this is referring to column. So what that I am marking here, look at this, observe carefully. So here this is referring to rows 2 is to 3 and 3 is to 4 is referring to columns. So here what is 2 is to 3? Now you look. 2 means what? So this is 0, 1, 2. So first is 2 is to 3. This is for the rows. 2 is to 3. It will start from 2, 0, 1, 2. So it will start from 2. So from this row. And 3 means it will 3 minus 1. 3 means 3 minus 1 means again 2. It will end in the same row only. It will begin there and it will end in the same row. And also, where is the column? It will begin from the third column. So third column means what? So A is the 0th column, B is the first column, C is the second column, D is the third column. It began from the third column, and 4 means 4 minus 1. It will end at the third column only. So 0.98 should be the answer. So what should be the answer? So what is this? 0.98 should be the answer. So let us print, because I have changed the value. Yes, 0.98. 0.98 is the answer. So regarding this, any doubt? It means here inside the data frame, any value can be accessed with the help of index. With the help of index, any value can be accessed. Any doubt here? Huh? Are you fine? No doubt. Getting what I am doing here? Able to get? Yes, please answer something here. Otherwise, what I should understand. Yes. Okay. So, pandas. So like this. Similarly, look at this. If I want, so what is this? You can change any values here. So what is this? It will begin from first row. 4 means 4 minus 1, 3. First row to third row, and first row to third row for the row values, and for the column values it will begin from first column. 4 means 4 minus 1 third. So first row to third row, first column to third column, that values I want. So let us see. This is the first 0 means 1 means second. So first row means 1 means second. Sorry, 1 means second. Second row to 4 means 4 minus 1, 3. Second row to third row. Second column to third column. Why it is second to third? 0, 1 means second column. 4 means 4 minus 1, third column. So 2 to 3, 2 to 3. So 2 to 3 row wise. 2 means 0 is A, B is 1, C C is 2 to 3 D. So only 0, 7, 9, 8, minus point 2 and 6, 1. So these values CD, only CD, only these values should come. Only these values should come. So let us execute and check this. See, only these values came, starting from 1. This these values, only these values are come. So you can execute any part. You can execute any part or any. You can fetch. You can slice. So that is the capability. See, what is this? Df dot. What is this? Fetch 4. So what is this? Everything. So if I say df z is equal to, I am assigning df is this is already df. This I am going to assign it to z, and I am using ilog function. So start. See here also, this is start. This is same thing. Inside that, if you want, here also you can do 1. Here also you can do start, stop, step. Everywhere start, stop, step. So look at the same. So if I give 2 here, step, the values might get reduced. So look at this. See? See? So something like this. So these are some kind of same ilog function also works in the same way. NumPy also works in the same way. Start, stop, step. Everything, whatever the indexing concept is same, irrespective of whatever the data structure, data type it is. Okay. So now that is about ilog function, and yeah. See, you have to tell me now. See, look at this fetch from second row, all the second row, all values of rows, and the third column only. So what is this? So something like this. You see again here. You have to go and try ilog, because this is quite simple concept. If you, once you understand it is same. See, what is this? From the third means fourth row. 4 means 4 minus 1. So this is 3 to 4. 4 means 4 minus 1, 4. That is only one value you will get. And see, 3 means what? 0, 1, 2, 3. That is 3 means fourth row. 4 means what? Here it will start from 4. Where it will end? It will end at 4 means 4 minus 1. That is again 3. 3 means what? Third row. Third row. Here also 3. Here also 3. So only one value you are going to get. So this is what? See, look at this. This is 3, 0, 1, 2, 3. It will begin from 3. Okay. And where it is going to end? It is going to end at, this is what I am discussing, right? 4 means 4 minus 1. That is also 3. Where is 3? So this is minus 0.82. Minus 0.82 should be your answer for this one. For this one. Because anyhow, we have random number I have changed. So look at this. What happened? Z is not defined. Where is Z? Is not Z. Okay, we have not defined that. Okay. So 3 means, okay, 1.39. 1.39 should be the answer here. Look at this. Minus 0.2. Where is minus 0.2? Minus 0.2. Z dot ilog. Second column. Okay. 0, 1. Okay. Yes. Minus 0.2. Look at this. How it is? So here it will start from 3. Where is 3? So 0, 1, 2, 3. It will start from 3. Yes, this one. And where it will end? It will end at 4. 4 means what? 4 minus 1, start and end. 4 minus 1 is again 3. So again 3 is the same row. The same row. Next I will put comma. So I will put comma. So I will go to this second column. Second one is for the column. So column, from where it is going to begin? It is going to begin from 2. It is going to begin from 2. 2 means what? 0 is A, B is 1, C is 2. So this is 3, and in the 3, so 2 means C. C means minus 0.22. So that is what you got here, minus 0.2. So any value can be fetched. So again, if you column, if you are going to put like this, you want where the column should end. If I put like this, so it will end at not only just the second column. So this is second means C, 3 means D, 4 means E. Till E it is going to go. So look at this, so many values will come now. Where is this? Where is that? Yeah, not just 0.22. Look at this, along with 0.22, D also will come, E also will come. Okay. So I think this should be clear. ilog function, start is for the rows. I am repeating again. Comma, then it is for the columns. So this is again for the rows, start and end. And if you want to add, this is optional. If you want to add step, you can add. If you want to add step for next comma, this is for the columns, start, end. If you want to add for steps, you can add like this. You can add like this. Okay. So this is for the ilog function. So we use ilog function. We use just, people are comfortable using ilog. I don't know. No, you should use, because data frame there are no other option left. Indexing has to be done with the help of ilog function only. Ilog function should be used. Yeah? Okay. So instead of ilog function, without ilog function, if you want to go with, you can go. No, but anyhow, it's better to use ilog function. See, look at this. This is for starting from the second row. That's all. Then you leave it. Everything is going to be displayed from second, from 2. Okay. So this is from the column. So it will end at 2. So start, stop, and if you don't want to do anything, so this is your df. Look at this. So if you want to do from 2, so you can do lot of things. So I am putting 2 here. So this is for end. End means, look at this, it will end at only 2 minus 1. So 2 minus 1 is 1 at the 1th column, or the first row. So it will end here. Okay. So steps you want to take it as 1, or if you want to end it at 5, and steps if you want to take it at 2. You are not mentioning anything. By default it will take from 0. So look at this. By default it took from 0. 5 means 5 minus 1, that is 4, and step is 2. So several ways you do your analysis, how to index slice. You can practice that. So same ilog things are there. So this you can understand, not an issue. Simple. So look at this. What is this? Look at this Z ilog. This is for the rows, comma, columns. Column just minus 1. Minus 1 means the last column. Only last column, everything is coming. So negative indexing I am not comfortable. I have already told you, not good practice. People who are using very good at negative numbers, you are welcome to do this. Okay. So that is regarding the indexing. Similarly, in Pandas you have merge, concatenation, join and append operations are there. Look at this. So you have data, subject ID, first name. So you have 1, 2, 3, 4, 5. So inside the dictionary, dictionary, and inside the dictionary you have list. So key value pairs are there. So key value pairs. So you convert that convert them into data frame. So when you convert them into data frame, so this is what it is. So subject ID, first name, last name. So you are not going to view this also. Look at this. By default, it should be there because it's a dictionary. So look at this. See, subject ID. Even though if you are not going to mention columns also, by default, because it's a dictionary, it will take. But why I am doing this? For my understanding. For why for my understanding? Because I am going to use this data frame. I am going to have a similar data frame where I am going to use merge or concat or something, join and append. I am going to use it. Okay. For that reason, I am doing this. Okay. Look at this subject ID you have, first name you have, last name you have. You are using this. So this is a data frame. So I am creating a data frame. So this is what subject ID, first name, last name. Okay. So indexing by default it will take from 0. You have one more data. See, subject student name is there, last name of the student is there, and what subject ID student is studying, that we have. Similarly, one more, let us say we have one more class. Here also you have first name, here also your last name, here also your subject ID. I think yeah, names. Okay. Here also you have. This is also DF. Okay. You have one more thing. Same. Let it be, if it is same, no problem. You have one is called as DFA. I am calling first one as a section. Let us say it's called DFA. One more I am just saying that it's DF. Same subject ID, first name, last name. Let it be as it is. So I'll go for another one, B section. Okay. There also students are there. They have first name, they have last name. They are also having subject ID. 9, 10, 6, 7, 8. They are also having subject ID. Look at this. So here also I will convert them into data frame. So I will define the columns here also. So this is B section. So this is B section. So now what I have to do? I just want to add club the students from both A section and B section. So DFA is A section. So DFB is B section. What is simple? DFA plus DFB. This you can do only when it is say 0, 1, 2, 3, 4. Here also you see 0, 1, 2, 3, 4. Then rows and columns are going to match. Rows and columns are going to match. So easily see what is happening here. You are clubbing, you are adding. See what is the subject ID? See 1 is there. Here what is this? 9 is there. 1 and 9. See it's showing as 19. It's actually not true. Subject ID for each subject is unique. So this is not going to be good case. So in such case, first name, okay, first name is also getting added. See, this is a first name of the student present in A section. So first name of the student present in B section, and they are getting clubbed. So this is not good. Okay. So instead of that, okay, we will see one more criteria. Okay, I will take C section also now. DFC. You also have subject ID, test ID. See, this is with respect to examination department. Let us assume like that. You have two sections, A and B, and C section is only with respect to exam department. You don't have student. You don't have the student name. Only you have subject ID, because for each subject you have to give the exam, and for each subject the test ID will be different. Okay, and okay. So now I will print this. So I will keep this. So this is DFC. So this is also row column, row key value pairs, subject ID, test ID. So this. So now what I want to do, if I want to club, so I told you. So plus is not going to be good. This is not going to do work. This is not good practice, so we will try to concat. Already you know concat. So DFA, A section, B section. Okay, what is this? Axis is equal to 1. Axis by default it is going to be 0. Even if you are not going to write axis is equal to 0, it will take axis is equal to 0 only. Why? Because axis is equal to 0 means row. Okay, so it will concat on the rows only. So now you see 0, 1, 2, 3, 4, 5, 5 students in A section. These are the DFA, these are DFB, 5 students from the B section. Now I have clubbed them. Now this looks fair. Okay, I have clubbed. Subject ID is there. So first name is there. Last name is there. This looks fair. Okay. So now what I have to do? So I have to concat. So if you are going, this is axis is equal to 0. When if you even don't mention also, it will concat like this only. But if you mention axis is equal to 1, it will concat on the columns, not on the rows. So look at this. Subject ID 0, 1, 2, 3, 4, 5. Again subject ID. So this is not good, right? What is this? Why you have to mention column twice, two times? Huh? So this is, but still if you want to concat like this, actually it will concat on column wise. Okay? Similarly, simple concat without mentioning axis is equal to 0 also, same thing. I have already told this. Next is that is about concatenation. Okay, this and a lock function you already know. This is okay, yeah, this already you know. Oh, merge. Now you see, where is df new? Okay, now I concatenated. So concatenated value I called it as df new. Means what is this df new? Here I concatenated as df new 1. Look at this. Axis is equal to 0. I called them as df new 1. Okay, let it be as it is. df new 1, no issue. This is a concatenated set. df new 1, no, I am not concatenated. Where is this? Okay, this is df new 1. Okay, the same one you will get here. I have concatenated both 0 1 to A section and B section, both student subject ID, student ID. Okay, and you have DFC. What is this DFC? I already told you. This is examination section, not A section, B section. See, only test IDs and student ID. Sorry, subject ID. Raw data you have. Raw data contains subject ID, test ID. This raw data, subject ID, test ID converted into data frame. The raw data I have put inside this data frame, and I call this as DFC. What is this? This involves only test ID, subject ID. Now I want to, what I have to do? I have to, this is DFC. DFC is having subject ID, test ID, but there is no student names here. Okay, there is no student names here. And here in case of your df new, observe carefully. Where is this? Df new. Yeah, df new. You have both A section, 5 students from A section and 5 students from B section. Their subject ID, first name, last name. In the DFC, you have only subject ID, test ID, as we saw now, because only subject ID is there and test ID is there. Student name is not there because this examination department. So let us assume they don't want to reveal the student name. Student name should be masked before evaluation. Only subject ID will be there, test ID will be there. Okay. So now what I have to do? I have to club these two. Business logic is df1. I can club. So if you want to in SQL also you are using the same concept. Now see, this is a table. This df new is related to table dfc, and they are interconnected. There are common attribute for both the tables is subject ID. Yes, Examination subject ID should be there. Student is writing subject, that is going to have ID. If evaluator is going to evaluate the student answer sheet, and there he is going to write the subject ID. That is common. Yes, that is to be common, right? Yes. So if you, what you can do, you can merge. What is this? You are going to merge. What is this? Both DFC and DF. DFC and DF new. I am going to merge. So look at this. PD dot merge, simple. DF new, DFC. How? So now all these things will come into picture. Outer, inner. So what is outer join? Tell me. You know na SQL. What is outer join? Outer join involves duplicates or not? Hmm? Outer join. Forgotten, huh? Inner join means only outer join. Outer join. See. Inner join, left join, right join, outer join. See, outer join. Right, left, full. Full outer join. So here you see duplicate values are going to be taken out. Whenever you are going to merge, you should remember one thing: duplicates values will be eliminated. Anyhow, there are no duplicates here. You can check. So I can do one thing. You can put duplicates and you can check. So now I am merging DF new. So DFC on what? How is equal to outer? Anyhow, or you can use on this subject ID also. You can merge. Okay, I am not merging on subject ID. I am just merging on outer merge. So subject ID is there, first name is there, last name is there, and their test ID will come. So there is a possibility to merge everything. Inner merge is not there. So 1 minute, I will just show you if it is not the case, how you can merge. If that is not the case, on I don't know whether it's going to work in Pandas here. Copy. Let us check. Okay. Yes, look at this. Instead of how, what you can do? You can merge on what? You can merge on subject ID. Why a subject ID? DF new one, DFC. This is DFC, subject ID is there. Here also DF new one, subject ID is there. Common is subject ID. You can merge on common column, that is subject ID. If you mention instead of subject ID, if you paste it something like this, see what is going to happen. See, key error. So it's not going to work. So it also always has to be the common column. So common column is subject ID. So I will put subject ID here. Or instead, if you are confused, merge outer join outer. Okay. So you can merge all CRUD operations, whatever you are doing in SQL, that is possible here. So similarly, raw data, what is there here, same. That is one thing. So any doubt on merge? What happened? This is a different story. Okay, now similarly, anything else needs to be told to you. Merge is over. This is same example, subject ID, first name, last name, DFB, over, DF raw data, DFI, what we are doing here, DFA, DFB, already there, I am printing that, okay, DFA, DFB, yes, that also, okay. This I have already told you. See, like this also you can do. See, how on subject ID, how is equal to outer. See, outer join, what is happening in the outer join? So if you see inner outer, where is this? See, nothing is going to come. Common column, outer join. So left side you have DFA. This is the table that you have on the left side. That is this one. I will tell you it so that you can understand clearly. Left side you have this. There is DFA. This is DFA. Okay. So similarly, what you have? So what you have? DFB. So what is DFB? This is DFB. So DFB is this one. Subject ID, first name, last name. First, it's not DFB. Is this DFA? DFA and DFB. We'll separate it so that you can understand. DFA. This is DFB. Yeah. This is DFB. So the right side you have DFB. So here what is going to happen here? So this is Alex. One same only, no? This is same. Okay. So this is DFB. So you have, this is left side you have DFA and right side you have DFB. Look at this. You want to club it. So if you want to club it, what is going to happen? It is outer join. Everything is going to be included. Full outer join. Everything is going to be included. So what is going to happen here? Union means it's going to remove the duplicates. Union all means all duplicates will be included. Here it's a outer join. Outer join means everything is going to be included. So A is there, B is there. So it is going to somehow come and fit something like this. This is outer join. So A, B nothing is there, and B, A side nothing is there. A plus B nothing is there. So something like this it's going to come in the form of a matrix, it's going to fit. So that is how the output is coming here, something like this. If you see here, what is that the output? So here on subject ID, the base is subject ID. Okay, so because for both the columns subject ID is common, so that will be the base. Based on that, A side, yeah, you have Alex Anderson Army. Okay, but with respect to subject ID 1, in B no one is there. With respect to subject ID 2, in B no one is there. Similarly, with respect to subject ID 9, no one is there in A, so non value, but student by name Billy is having a subject ID 9, and in A no one is there, so that is why it is 9. So that is the meaning of outer join. That is the meaning of outer. So it will be able to identify with respect to a particular column attribute. The particular column attribute here is subject ID. Okay. So that is the case. So now that is how the thing is going to work here. Okay. So pd dot merge dfa dfb. So non values are going to be present, and you want to check with respect to subject ID any student is present or not. So you have to merge like this. Sometimes you want to merge something like this. You want to check with respect to what the data is present. Okay, something like that. So that is about merging. Simple merge. Say same here. Look at this data frame. You have HPI, Human Performance Index, interest rate, Indian GDP. So you have these values. These are the values. Okay, dictionary inside this list. So index again Indian GDP, again Indian GDP 2. Then index I am starting from 2001, 2002, year 2001, 2003, 2004. That should be the index for the years. See another DF2, 2001, 2002, 2003, 2004. So look at this Human Performance Index, interest rates, Indian GDP. So look at it, it's coming like this. So I am separately printing DF1 and DF2. This is DF1 separately, and this is DF2. And if you want to merge DF1 and DF2, what is happening here? So nothing is coming. See, you are unable to merge. So let us say which is merge DF1 comma DF2. I will say on is equal to. So on what I have to merge? Let us merge on. I will merge on HPI. Okay, I will merge on this HPI. Let us see. Unable to merge. Yes, because they are different. Interest rate pd dot merge. Let's say how is equal to outer. So look at this. You are able to merge now. See, I am able to merge. How is equal to outer? I am merging on common column. Common column is HPI. Interest rate is also there. You can merge on interest rate also. You can merge on Indian GDP also. So like this, data frames can be merged to extract the meaningful outcome present in the data. So that is how we are going to use it. Okay. So this is regarding merging of Pandas data frame. Some more any other functions, let us see. Same thing here also. See, whatever I told you, again I am telling the same thing. Data from EDFC, nothing is there, merging only. This I think I have already sent you, concatenation and merging. So this is what operations we use in Pandas: merge, concat, append, iloc for indexing, and some other functions if are there, that we will discuss tomorrow. Already 8:45. So I will stop. I will give another 5-10 minutes, another 4 or 5 minutes. So any doubts are there, kindly ask. So I will stop the recording.